Alright everyone, it's Mr. Rops here, and we are going to do right triangle trigonometry problems. And one of the, a reminder from the past, when we were doing a right triangle trig, I'm going to remind you of SOHCAHTOA. SOHCAHTOA. Right? Because we know that sine is equal to the opposite over hypotenuse. Cosine is equal to the adjacent over the hypotenuse. And tangent is equal to the opposite over adjacent sides. And so if we take a triangle, some kind of a triangle, right? It's a right triangle. And if I call this side, let's say this is theta. From theta, if I want to find, I always know that this is the hypotenuse. That is fixed, that never changes. But from theta, this is the opposite side. And this is the adjacent from theta, because adjacent means next to. However, if I would change here to alpha, now this is the opposite side, and this is the adjacent. And so you have to choose the angle you're looking at, and that defines which is opposite and adjacent relative to the angle you have. Okay, so that's just a reminder of how this works. Okay, so SOHCAHTOA, opposite over hypotenuse is sine, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. You need to memorize those and have them solid in your head. Okay, let's try a problem now. So take a moment, read this problem. Let's see what it is. A survey has placed two posts, B and C, which are 120 meters apart, nicely shown in the diagram, on one side of a river. He crosses the river using a bridge and moves to a point A, which is directly opposite B. So that means there's a 90-degree angle here because it's directly opposite. He finds that the angle of sight between the posts is 37. So this angle here is 37. How wide is the river? So I'm looking for side AB, which I'll call W. So from 37, I know here is the opposite side. And then W, what I'm looking for, is the adjacent side because it's next to. AC would be the hypotenuse. So if I have opposite and adjacent, that is the tangent relationship. So the tangent of 37 is equal to the opposite side, which is 120 over W. Okay? And so if I'm going to solve for W, I multiply both sides by W, multiply by W on both sides. That will cancel it. And so I have W tangent 37 is equal to 120, dividing by tangent 37, both sides. That cancels, and I can see that W will be 120 over the tangent of 37. Okay? If we note, that's in essence, I can just switch those two around. So I could have went straight from here, straight down to there. Because the reason why I can do that, imagine if I have this fraction, I know that 2/3 is equal to 4 over 6. What I'm going to do, or my fractions, I'm going to switch those two values around and see what I get. So if I go 6 over 3 and 4 over 2, this is still a correct statement. This is 2 and this is 2. So I can just in essence switch those. So to find what W is, W, I just throw this in my calculator. And so I know this is tangent 37 degrees, so I'm going to go to my calculator. I have to go to my mode. I have to make sure I am in degree mode. Okay? Once you change it once, you shouldn't have to change it again, but you should always check it, especially if you're borrowing someone else's calculator. You don't know where it's been, but every so often, check it to make sure you're right. And so then I just go 120 divided by the tangent of 37. And so W is 159.25 meters. And so three significant figures, it's 159 meters. So how wide is the river? 159 meters. Okay, we'll try one more problem here. A train must climb a constant gradient of 5.5 meters for every 200 meters of track. Find the angle of incline. All right, so a train, so when I read this, a train must go up a hill of some kind. for every 200 meters of track, so if it's going up a hill, here's 200 meters of track. The train is coming up the hill, and this is 5.5 meters. Okay, so I'm looking for the angle of incline, which is going to be theta here. And so the train is going up the hill. Here is my train. Right, so if I want to find theta, again, I think about from theta, this is the opposite. And now from theta, this is the hypotenuse, because there is my right angle. And so recalling that opposite over hypotenuse is the sine of theta, which is equal to opposite 5.5 divided by 200. Now, if I want to find an angle in my calculator, I don't do sine, I'm going to do the blue one here, the inverse sine. And so theta will equal to the inverse sine of 5.5 over 200. And so I go second sine, 5.5 divide 200. And that gives me 1.575. So theta equals 1.576. If I'm going to do the degrees, so to 3 significant figures, 1.58 degrees is to 3 significant figures. So this is just a tiny little angle, a slight little incline on the for the train to climb. There's an introduction to right triangle trig reminder.